we're going to introduce on stage the man who's this is his party, actually. This is his event. Probably needs no introduction, but I'm going to do it anyway. He's the CEO of Software Improvement Group, Luc Brandts. And SIG recently released a report. He's going to tell us about the findings of that report and the sort of general state of software quality globally. Are we ready for that, everyone? Can we give Luc a very big welcome? Well, take it away, Luc. Over to you.
Here it is, the report I'm going to talk about. There's QR codes left and right. There's a few copies here, but I've also gathered some snippets. Of course, we first start with ranking. We love that, don't we? Looking at the different industries, who's performing best, who's not performing so well. There's actually a long tail of things. This is the top 10. There's also parts in there. Retail heading up this year's software quality. And we see also the public, so the governmental organization, doing quite well, actually, despite what you would read in the newspapers and people complaining about governmental software. It's not that bad at all. Doesn't say that nothing can be improved. We all know that, but it's not, compared to other industries, it's not doing too bad. Let's go to other things. When you have that software quality, what does it actually mean? You know, we might have this star ranking system, 1, 2, 3, 4, 5 stars. The difference between 2 and 4 stars is actually quite substantial. We've calculated. In the report, it gives you some examples for small systems and bigger systems, and this is about substantial amounts of money that can be freed up for innovation, for profit, for whatever you want to use it for, speeding up that pace of development. We'll touch on that a bit more in a second. This is also interesting, is what's the impact of size, so how bigger a system is. Let's look at the graph on the left. I'll try to explain it. The red swoosh are big systems, and the yellow ones are medium-sized systems, and the blue ones are small systems. And you there very quickly see that it's almost impossible to create a very large system at a high quality, meaning that it's easy to maintain, easy to extend. That's obvious, but that also means that what we have seen in the last couple of years, that the amount of smaller system is growing dramatically. People are divvying up those large systems into much more easy to maintain systems and therefore increasing the pace. And as a result, when you look at the last decade or so in how the speed of innovation is going, it is increasing. We do see that the average level of quality is increasing. That also means if you want to stay at the same level as your competitors, you will have to improve. If you stay at the same level, you will slow down as a result. On the right, you see also that modern technologies tend to be much better performing. Makes a lot of sense, and it's logical that that is the case, but there's also a drive towards getting rid of that legacy. So this is some basic software quality metrics. Again, read the report if you want to know a lot more details. This is just to give you some snippets there. Now, we also need to look at security. This is a top 5. Looking at security across the industries. You clearly see FSI, so financial services, doing very well, followed by energy and public, the software industry trailing, which is an interesting finding in itself, I feel, and manufacturing, for instance, lagging a bit behind. Now, when you look at, if you are part of the FSI industries, and I'm sure some of you are, you will find, oh, that's good, we're heading up the industry. But when you look at the details, being at roughly 3.5 stars, so slightly better than the market average, does mean that you have a lot of trouble. On average, you will have 19 critical findings in any given system. So being market average in security is really, really bad. I'm sometimes surprised to hear that companies are using so many security tools, yet still have so many security findings when we look into it. So that's a definitely a call to action on that end. So, as I said, I will go through some of the aspects, trying to trigger some ideas with you. We also look at the cloud readiness, again, headed up by FSI, a different range there. So how well are we prepared to make use of cloud solutions? Very well headed up by FSI in that sense. So there's other industries that still have a lot to do there. And of course, this is industry-wide, might be very different for you as an individual organization. If you want to know how do we stack up against our peers in the industry or the industry as a whole, yeah, let us know. We'll be able to find out for you. Now, this is a busy slide, so I'll try to explain it. This is on green IT. There's a whole section about green IT, and I just took a few things out. On the left, you see the efficiency per industry, where there's quite some differences, and you also see quite some opportunities to improve, specifically on the business services end, where it's really still quite poor. But on the right, we see a very nice, colorful slide, right top, of different programming language and how energy efficient they are. And on the right, you see Python. Happens to be the language that's used most in AI. That's quite energy inefficient comparing to, for instance, Java, that's somewhere, well, just above the word energy there, if you can read that. Or C, I wouldn't recommend using that. There's other reasons why you might not use it, but there is certain consequences when you use a particular language. On the right bottom, you see what would the impact be if you are refactoring that code. And we see an average reduction of 17% by looking at code and trying to optimize it for energy reasons. That's average. We also see that CO2 reductions because of location of data centers can be massive, can be up to 90%. So there's a lot of stuff happening here for sustainability reasons, but also for cost reasons. That's hidden behind this data. Happy to dive into that if you want to know more about this. We obviously also have to talk about AI. And we spoke about it last year, and we're going to speak about it next year, and probably in 2 years' time, somebody will be standing here being AI talking to you, rather than myself. Because when we look at AI, it has many different aspects. There's a different track on it, but we also want to show you that we have measured many systems that are AI or data analytics types. And when we look at the average quality of those systems, it's not looking great. And this is how this looks like. All the yellow dots are the average systems that we measure, so the normal systems that everybody has, while the blue dots are AI systems or data analytics systems. Now we see a couple of things. First of all, that the AI systems are not doing too well. We are creating tomorrow's legacy here. The easiest way to explain it, and I said this before, is every one of you, like myself, will have received a spreadsheet from a colleague saying, oh, this is a cool thing, you can use this very easily. Then you start to look at the formulas and think, let me recreate this because I have no idea what this is about. That's what those systems are. It's programming by data engineers rather than software engineers. And software engineering is a skill, as can be seen here. It also shows that it's not a law of nature that AI systems are bad, because you do see dots over there on top. So you can create high-quality AI systems. I wouldn't say easily, but it is possible. And another thing you can see is that the bigger systems tend to be of higher quality, meaning that the systems on the left are more experimental, although production systems, but as soon as they start to become bigger, they need to be better because otherwise it's impossible to keep them alive. Now, this is stuff you want to prevent because you don't want to be relying on things that go bad. Because, as you might also know, there is a direct correlation between this quality and the likelihood of a security incident. That we've shown in earlier research that there is a direct correlation. The difference between 2 and 4 stars is a factor 2 in the likelihood of a vulnerability. It's easy to understand intuitively. When you have a mess, it's easier to make a mistake. That's simply a fact of life. So these are just some snippets from the report. It's much more extensive. There's more data behind it that I'm happy to share with you. The physical copy is here, and the online copies are available through the QR code, as I said. It's really interesting to get to know this, and again, if you want to know this specifically for your organizations, let us know. But then comes the now what question. So, knowing all this, what do we need to do? And for that, I'd like to introduce a little graph here that I need to explain. This is the typical span of control that people in the organizations have. A developer will look at software code and might have an interest in architecture, but has no impact or span of control within the business structure, the enterprise architecture, or the business process itself. The architect will have a focus on the software architecture, will maybe less interested at the code level, and have very limited impact on the business processes, on the business structure. Whereas at the C-level, the focus is completely on the business structure. This already immediately, of course, per organization, the shades of blue might change. There might be developers that have a very keen interest or no interest at all in architecture. There might be architecture that are totally into code or very much involved into business structure. But this is sort of an average what we see. But we also see that there's a disconnect between a C-level and the rest of the organization, because they have a business language, whereas the other people in the IT teams, they have an IT language, and we need to bridge that gap. And for that, I'd like to introduce the concept shift up. You're probably very familiar with the concept of shift left, which is something you should definitely do. Shift left is the earlier you find the problem, the cheaper it is to resolve. But shift up is to get the focus on the things that really matter. If you go into the code level, there's certain things you can fix, but if you really want to fix it, you need to fix it at a more architectural level or even at the business level. When speaking to analysts, when looking at the data, we find that at the software code, that's where you maybe can find 20% productivity gain. You can find a lot more when you look at the overall architecture. And if you really want to go 10x, you need to look at your business. You need to look at how you do business and how that translates into code, into IT. The 20%, that's where the AI coding assistants work. We obviously get a lot of questions, and I'm sure many of you do. Should we be using Copilot and similar systems? And the answer is, of course you should. You definitely should, because it is improving your productivity. There are risks to it, and I'm pretty sure that the AI track will go into those risks as well. But there is a potential gain of, say, 20%. That's what most recent research says, which is taking out all of the marketing. That says 50 to 70%. But if you look at the overall productivity gain from things like Copilot, last week I was speaking to a CTO of a larger organization, and they measured 13-14% in productivity gain by using AI-powered code generation. But if you really want to step up, you can go into looking at your software architecture or even your business processes. So when we take that, oops, that's an animation challenge. So we have created this interesting organizational mess. These are all architecture things that are going together, and the reality is even much more advanced. And what we're now doing is using agentic AI and low-code systems and all stuff to create all things around it. And I've made a much more dramatic animation with what this entire picture would be very messy, but I don't like messy things, so I kept it this way. But the reality is, if we are using those techniques to very simply create stuff, then we will make this complex. And if we keep the things in the background the same, then we are focusing on that 20% while keeping the mess alive. So that's why we feel we need to shift up. Don't focus just on the code level. We need to go up to the architecture and the business level. So on the developer level, you will be doing refactoring, which will have its impact. It will give you the 20%. Don't ignore that, because there's real money there, there's real speed there. That's something that needs to be done. If you go to the architectural level, then let's speak about modernization. That 20 million lines of COBOL code, or maybe that 30-year-old system that has been developed over time, has gained, let's call it, a certain amount of technical depth that needs to be modernized. That's where you find the 200 to 400%. But if you really want to go 10x, you need to look at your business structure. You will find that you might have 7 systems that hold client data. Why? Why do we have 27 different products that do almost the same? Look at the business structure, relate that to your business, and that's where you find transformation. So depending on your ambition level and your span of control, you can be doing refactoring, you can be doing modernization, or you can be doing transformation. And it depends on, again, the ambition level and how much the C-level dares and how much the IT organization is able to do, which is always an interesting balancing act, where you will end up. We can help you at all levels, but it is something that we need to determine together where to focus on. Should we focus on the refactoring? Again, a lot can be gained, or shall we go all the way to transformation? So, with that said, and 3 minutes and 46 seconds remaining, I want to end this talk. So there is maybe a time for a question. If not, I'd like to ask Adam to come back to the stage. Thank you.
Thank you, Luc. Thank you, Luc. Cheers.
Thank you.
Thanks, Luc. Yeah. I was watching that, and I'm not an IT person, so most of it I didn't understand. But what I'm curious about is we're increasingly more dependent on technology and software in particular, and we've seen what happens when systems go down.
Yep.
And the chaos that can cause. How optimistic or pessimistic are you about the future of software quality?
Well,
is it getting better? Are we going to be more reliable?
It is getting better, but it's getting more. So I'm very optimistic about the future of Software Improvement Group.
Okay. The opportunities for you.
Exactly.
Okay. Gotcha.
Exactly.
Do you have any questions for Luc from the audience? Just put your hand up and I'll come round. Somebody must have a burning question.
Or use it in the break.
Yes, they're over there, right over there. All right, okay, here we go. I'll give you the microphone. Hi, thank you.
Hi, I'm Wilco Berghoff. My question is, for the shift up, what are the 3 main topics you discuss with C-level members?
I think you need to talk data. You need to talk facts. So I'm talking direction, and people will get that. But as soon as you start explaining, there's technical debt, and we need to get rid of it, they say, yeah, right. But you need to translate it into data. You need to tell them what is the situation now is that we're 45% slower than our competition, and as a result, our go-to-market will not be end of this year, will be end of next year, which is something you might accept. But if not, then this is, and that's another number, what you need to invest. And so you need to be concrete. You need to be talking facts. If you talk direction, you get what Adam said, I have no idea what you were talking about. You need to say, well, you're at this level of quality, and that means that you're going to be spending, I showed the numbers in the beginning, 6 million more a year. That's okay if you have the budget. If you think, that's a bit much, let's get rid of it, that's fine, but then we need to invest this. But that also requires choices from management. It needs to align business and IT. Very often, business is at this level and IT at this level. And business is complaining about IT because they don't get it. they have no idea what we're talking about, and IT says, these guys just keep on asking stupid questions and we keep on programming. You need to level set that. You need to understand why things are happening the way they are happening. And once you get that done, and that's where the facts come in. As soon as you align on the facts, it's really simple. I'll give you an example. Very recently we did an analysis where we showed that the ticket handling in an organization was as follows. Critical issues were dealt with very quickly, of course. High and medium issues were solved much slower, and the low priority issues were solved very quickly. Now, what does that say? That's a fact. You just look at the numbers. What does it say? That, of course, we focus on the critical issues, but for the rest, we determine our own priorities. And that's not good. That's where business and IT is not aligned. Again, facts, that's what helps. And then some arm twisting, but that will follow.
Can I twist someone's arm to ask another question? Here you go.
Thank you for the insights, what you mentioned. The problem that you state is actually a problem we have been having as long as IT exists. It's not a new problem.
Nope.
Do you see something changing now, especially with the upcoming of the AI, that would actually turn around this problem so we would be able to solve it faster?
Yeah. Well, we have the opportunity. The question, of course, is AI helping? Potentially. But it could also increase the problem. It could increase the problem dramatically because it's so easy to create a mess now. Everybody has seen these wonderful agentic AI demos where in no time something fantastic is created, which is fine. You should definitely do that. But you should also base it on if the ledger behind it, the system of records behind it is a mess, or like 15 messes where data is being shared, then you can build a lot of things on top of it, but it will remain that mess. That will also need resolving. And while AI is going so quickly, it might very well be that the disconnect between business and IT gets bigger because there's less understanding of that mess that's left behind. And that also needs fixing. So really explain that it's not just those small things that need to be happen, but also some of the things inside. Once that happens, it's an enormous opportunity, but as a result, always with opportunities, there's a threat. People might misinterpret it that big time. Okay?
I think we've got time for one more question, if anyone's up for that.
This says time is up.
Oh, from Daniel. There you go. Yes.
Let me try a question. So you mentioned that AI-assisted coding is improving productivity.
Yeah.
And the first question would be, how do you measure productivity, which is a really big question. But more general, have you looked at there also in the split between AI engineering, basically you build a software system and link it to an LM, or AI-assisted coding, and which kind of differences do you see here?
That's a very good question, and I'm not going to answer it because I don't have the data. Maybe some of my colleagues have. I can bluff my way out of it, but I won't. No, I think that's too soon to tell. The 20% that I mentioned are things that are here and there measured. But if we look at the overall productivity, so the amount of code that's being produced in our benchmark, we don't see a major shift. We don't see that 20% yet. So a lot is still done in traditional ways. So there's probably more talk than walk. But we do expect there where it's being used, that there's more code being produced, which is going into production. If you just look at what's being produced without the checks, then of course you can create a lot, but it does need those additional checks. But it's a great question, and it's ongoing research. We don't know yet. Or I don't know yet. Maybe that's a more honest answer.
Thank you, Luc.
Okay,
Thank you. Thank you. Thank you.